Good morning, children. We proceed on to chapter 9, Applications of Integration. Having learnt various methods of integration in standard 11, we proceed on showing that integral as a limit of sum. We proceed on to show integral as a limit of sum. Sum, the word tells us addition. So ordinary addition, we write sigma r is equal to 1 to n like that. When it is extended, this is extended like this, we call integration. So we want to mention integration is a limit of sum, but now n tends to infinity. It is not ordinary summation up to n, but n tends to infinity. When you are given a problem like this, the lower limit I compare and write 0. The upper limit I compare and write b. The function you call f of x. Now this I compare with integral a to b f of x dx. To apply in the problem, we find out b minus a by n, that is 1 minus 0 by n, which is 1 by n. As I have calculated, let me substitute in the formula integral 0 to 1 5x plus 4 dx equals to limit n tends to infinity b minus a by n, that is 1 by n, sigma r equals 0 to n. What is f of a plus r into b minus a by n? How to calculate? F of a, what is a? 0 plus r into, what is b minus a by n? 1 by n. That is f of r by n. This is f of x. Wherever x is coming, put r by n. 5 into x is r by n plus 4. Substitute this in the formula. A plus r, b minus a by n we have calculated. So f of that value is 5r by n plus 4. While finding sigma, I will have sigma r square r cube. So we must remember the formula 1 to n. R comes, it is n plus 1 by 2. If it is squares, r squared. Sigma r square is n plus 1, 2n plus 1 by 6. And for cube, we have n squared, n plus 1 the whole square by 4. Look at this problem. I have sigma 5r by n. Keep 5 by n out. Write sigma r. Sigma is only for r. Keep 5 by n out. Plus sigma 4. How to simplify? Limit n tends to infinity, 1 by n into 5 by n. What formula we learned? Sigma r is n plus 1 by 2 plus sigma 4 tells me 4 I am adding n times. So I will write 4n. Check what all I can cancel. 1 n gets cancelled. Now I am left with limit n tends to infinity. Keep this n in. So I multiply with both the terms. 5 n plus 1 by 2 into n plus 4n by n. Again n cancels. I am left with limit n tends to infinity 5 by 2 into split and write first term by denominator plus second term by denominator plus 4. N cancels one time. Now wherever n comes, let me put infinity. I get 5 by 2 into 1 plus 1 by infinity plus 4. Whenever infinity comes in denominator, my answer is 0. 0 in the denominator gives infinity. Infinity in the denominator gives 0. So forget this. I have only 5 by 2 into 1. So what is my answer? 5 by 2 into 1 plus 4. Taking LCM, it is 5 plus 8 by 2 or 13 by 2. So the given question, integral 0 to 1, 5x plus 4 dx equals to 13 by 2. We are going to verify using ordinary integration formula. Integral 0 to 1, 5x plus 4 dx. Let us remember what we learnt in standard 11. 5, x will become x square by 2 when I integrate, plus 4 will become 4x. Put upper limit minus lower limit. That is, wherever x is coming, put 1, minus wherever x is coming, put 0. But 0 into anything 0. So forget it. Simplifying this, again I get 13 by 2. So as I verify using integration formula, I get same answer. This is only optional to verify, not necessary to do. So here we have done integration as a limit of sum. Limit n tends to infinity. So summing up to infinity is nothing but integration. Just quickly recall the steps. The very first thing we must remember the formula. Integral a to b f of x dx is limit n tends to infinity b minus a by n sigma. R is from 0 to n, f of a plus r b minus a by n. Given a problem, lower limit is a, upper limit 1, the function is f of x. What is b minus a by n? Let us calculate. Find out a plus r b minus a by n and f of that. What do you mean by f of that? Wherever x is coming, let us put what is here. That is r by n. As I substitute, sigma is only for r. The remaining I can bring out. So 5 by n sigma r plus sigma 4. Sigma of constant tells me that into n. Sigma r, let us remember the formula 1 plus 2 plus 3 up to n is n into n plus 1 by 2. As I substitute and I bring 1 by n in, I try to simplify and try to bring n in the denominator alone, so that when I put the limit 1 by infinity will tend to 0. The remaining numbers will add up and give the required answer. Question number 2. Integral 1 to 2 4x square minus 1 dx. Compare it with integral a to b f of x dx. Let us write. What is a value? 1. B value upper limit 2. What is f of x? Given 4x square minus 1. Let us find out what is b minus a by n. 2 minus 1 by n, that is 1 by n. As we try to find out a plus r b minus a by n, it is a value 1, r into b minus a by n is 1 by n, or we get 1 plus r by n. We want to find out f of, so I will write f of 1 plus r by n equals, in f of x, wherever x is coming, substitute 4 into x square. What is here? 1 plus r by n the whole square minus 1. Simplify this. We get 4 into 1 plus a plus b the whole square. A square, b square plus 2ab minus 1. As I multiply, 4 plus 4r square by n square plus 8r by n minus 1. 4 minus 1, I can write 3 plus 4 by n square r square plus 8 by n into r. Let us substitute in the formula. What is the formula? Integral a to b f of x dx equals to limit n tends to infinity b minus a by n sigma r ranges from 0 to n f of a plus r b minus a by n. In this question, we have 1 to 2. 4x square minus 1 dx equals to limit n tends to infinity. B minus a by n is 1 by n. Sigma r ranges from 0 to n. F of the answer that I got 3 plus 4 by n square r square plus 8 by n into r. Limit n tends to infinity 1 by n. Sigma 3 will become 3n plus keep 4 by n square as it is. Sigma r square will become n plus 1, 2n plus 1 by 6 plus 8 by n as it is. Sigma r will become n plus 1 by 2. As I recall formula from here, sigma r square, sigma r. Simplify by taking n in. 1n, 1 square cancels. 1n cancels. 4 2 times, 6 3 times. 2 4 times. Let us simplify taking n in. Limit n tends to infinity. 3n by n plus 2. Here there is a bracket n plus 1 by n. Here there is a bracket 2n plus 1 by n. When I take this n in, there are 2 n's here. There are 2 brackets here. Put 1 n for each bracket. Plus, there is by 3. Remember to write it here. 4 left out. N plus 1. Here I have n. So, I will write n plus 1 by n. Let us see the step once again. 3n by n plus 2 by 3 into. There are 2 brackets. Here there is a n. When I multiply, here there is a n. Associate one n with the first bracket, another n with the second bracket. Plus 4 into. There is only one bracket and there is one n out. So as I multiply with each term, see how we cancel. Limit n tends to infinity. 3 plus 2 by 3 into. This is n by n plus 1 by n into 2n by n plus 1 by n plus 4 into n by n plus 1 by n. As I take limit n tends to infinity, 1 by n will become 0, 1 by n will become 0, this 1 by n also 0. So I am just left with 3, 2 by 3 into 1 plus 0, 2 plus 0, plus 4 into 1 plus 0. As we simplify, 3 plus 2 by 3 into 1 into 2. So 2 into 1 into 2, I can together write 4 by 3 plus 4 into 1, 4, or 3 plus 4. 7 plus 4 by 3. LCM 3 cross multiply. 21 plus 4. My answer is 25 by 3. As I simplify, let me check with the ordinary integration. So my answer is integral 1 to 2 4x square minus 1 dx, and it is 25 by 3. How am I to verify? 4x square will become x cube by 3 minus 1 will become x between the limits 1 to 2. It is 4 by 3 into 2 cube minus 2. Upper limit minus 4 by 3 into 1 cube minus 1. As I take LCM and simplify, it is 8 4s are 32 minus 2 3s are 6 minus 4 into 1 cube 4 minus into minus plus 3 1s are 3. As I simplify, I get 25 by 3. So, as we check ordinary integration and integral as a limit of sum, we arrive at same answer.